So good morning, everyone. Let's get started before the official start, I guess. But so this is the hackathon project that me, Artem, and Rajesh did on the Zama Phoenix hackathon. So we got one of the runner-up prizes, so that was quite nice. And yeah, our idea was regarding private DAOs. So we very creatively named it Privagon. So yeah, let's explain to you guys what we came up with. Yeah, so needless to say, DAOs are very big. So there are more than 2,000 something DAOs right now. So they have various formats, various sizes. Of course, Aragon is one of the main ones, allowing people to create DAOs. They have different modalities there and different ways to create DAOs. There are over 7 million voters, so people are trying to participate in those DAOs, delegate votes, vote for them, and kind of have participation across a, let's say, a common goal. I'm going to mention constitutional DAO in a second. And DAO total treasury is over 23 billion, so kind of big. Anyway, important topic. But they can be even bigger, right? So the goal here would be that every private corporation could, in theory, be a DAO. So allowing for easier coordination on chain, more transparency, and so on. So there are pros and cons to that, but in theory, that would definitely be possible. But yeah, one of the things, corporate privacy is not there in the DAO if everything's on chain and public. So there are other ways that we need to leverage. One of them is fully homomorphic encryption. ZK proofs, of course, play a huge role in here. So yeah, that's the goal. So real corporate privacy. Yeah, so we need DAOs with private space. The current state of DAO. So anonymity is pretty much solved. So you can have anonymous voting using ZK proofs, for example. You can have anonymous membership. And also some of the examples here that actually Artem looked for. There was a proposal from Nouns DAO where they were trying to select 3 teams for 3 months with a grant of 70K. And for doing exactly that, what we did in roughly 1-2 days. So that was pretty amazing what we were able to achieve with the Zama and Phoenix tools. And the other thing, constitutional DAO that I mentioned, they were a huge effort, but they were also outbid by another competitor by $1, I believe, simply because it was public how much money they had and how much money they were able to offer. So with our solution here, that would not have been the case. So you could also have this kind of private balances. Cool. Yeah, so AHH and MPC is a game changer. Now what we did was we were able to store a secret with a dynamic review access. So we were able to upload a secret on chain and have this secret actually being encrypted. I'm going to go through a small diagram afterwards, but you could also only review the secret for members of the DAO. So that was kind of interesting. Define when value can be decrypted. So that's the dynamic review part of it. And finally, the arbitrary computations and encrypted data, that's where AHH shines, because you're able to calculate means, or able to calculate the averages there, and also do the summations on the votes, depending on how the person voted, not only for, let's say, yes, no, but also abstain. So that's where the fully homomorphic encryption shines. And the MPC, not sure how much you guys know about Zama there, but they basically uploaded a public key on chain, and they shared that across all validators using MPC. So that's why you're able to do AHH on chain. That's the naive idea. Cool. And yeah, we did private DAOs. The idea for private DAOs was mostly around voting on proposals. That's really the use case that we had. So yeah, the DAO members can now store secrets only accessible to the members. So I'm going to go through the diagram afterwards, as I said. Also, the voting proposals are encrypted in the sense that the votes are anonymous, and also the votes are not biased. So you do not know how many votes the yes proposal has had and a no proposal. So unbiased unbiased tallies is interesting. What I also find interesting, the DAO membership criteria is hitting. So nobody has any idea who's a member of the DAO, which is kind of impressive, because the criteria is also defined when you're constructing the contract. As I'm gonna show later. So there is no way somebody can tell you, hey, you are a member of Privagon, for example. That was also kind of nice. And yeah, voting secret. Cool. Yeah, so those are a little bit of the contracts there. Not sure if everybody can see this, but two main functions: upload secret and get secret. Regarding secrets, let me skip a little bit forward here. Morning. Cool. So as I said, we have the proposals voting, right? So here's the proposal. We have a file. We upload the file encrypted. We create a key. We use this key to encrypt a file to IPFS. Cool. So it's an IPFS. Nobody knows what is in there because it's encrypted with our key. It's a symmetric key, by the way, AES key. Cool. So now we upload this file encrypted to the DAO, so to the DAO contract, and it's there. Only members can see that we uploaded that, and also that there is a key in there. So everybody with the key can see the proposal. Nice. So a different person, a different member of the DAO is able to download the key also encrypted, and decrypt that in his local machine. So now I also have this symmetric key. And with the symmetric key, you're able to read the proposal and then afterwards vote on the proposal as well. Everything private, everything encrypted. So that's kind of nice. And that's also the use case. Going back to the contracts here. So yeah, that's the secret storage where we manage the secrets. So you're able to upload secrets and you're able to download them in an encrypted way. Also, if you guys notice the prefix E before everyone, it's encrypted, so very creative. But that's a Zama thing where they abstract away this kind of encryption part of things. You're able to just handle those guys here, basically. Cool. Then it's the mini-me, which I mentioned before. This is encrypted mini-me is basically the ERC20, but with a time aspect to it. So you're able to say, I don't know, Harry had a balance of 10 secret USDC20 at that block, and now at the next block he only has 5, so it's able to track those balances. And now is where the interesting thing comes alive is the private DAO contract. So here you're able to vote in an encrypted way. So you have an encrypted vote option here, and the proposal ID. We retrieve the proposal. We check if you have enough balance here, so that's your weight as well. And this weight is also, so the balance of is private. So nobody knows what each other balances are. So it remains a fair voting process, basically. So you don't see, hey, Harry has 1 million tokens and he voted already, so all my tokens are useless. So this remains kind of fair. And also, finally, this is member is what I mentioned for private membership. So only the members of the DAO are able to vote on that, and nobody really knows what is the required conditions for being a member of the DAO, which is also interesting. Cool. I went through that already. Cool. And yeah, the demo is not really that impressive. I was just showing that the upload and get secret process. So you're here, you have a key 8 for something, and then it's just running a normal hard hat test, which we integrated with Zama, me checking the time. And then we are able to see, hey, we uploaded a secret, encrypted, and we are able to fetch the same secret as if I was a second user. And with this other secret, I'm able to decrypt the proposals and vote on them. Yeah, just me checking the time there. But anyway, the key is gonna match this other key. So uploading secret, downloading secret, nothing too fancy. Yeah, I'm gonna skip through this. Yeah, that's it from my side, guys. So if you have any questions there, let me know. I still have a bit of time, so go ahead. 7 minutes.
So the AHH comes from the protocol that you use?
Yeah, they have a library there at Zama, and that's it.
And then they invented the EUS-UA256 kind of that as well.
Yeah, that's called encrypted ERC20. So that, yeah.
So is that Solidity or they extend from Solidity?
No, that's all Solidity. That's all Solidity.
So that's like
they do have a local chain as well that you're supposed to use because they have some pre-computes in there. So that's why you should use their chain. But this is all Solidity, so nothing too fancy.
And then E whatever you call it, that is like
that is a library. Okay. That is a library, yeah. And the one thing that we found a little bit complicated was, I'm not sure if you can see from the contracts here. There are some things like a CMUX, which is the if statements, because every time we're doing an if statement inside this contract, you're leaking information. So it's kind of ineffective that you have the CMUX and then you have a condition in the middle. It's like an if analysis, like a ternary operator. And there you're calculating both sides of the if and else statements at all times. So that makes life a little bit more complicated. And the gas usage is also not amazing for those contracts still. Yeah, so it's low. FHE is low.
So they use call data for all the transactions, because I think it will use encrypted data for contract.
Yeah, I was speaking to somebody about this. They also have the storage capabilities, so you're also able to store things in the contracts because they're encrypted at the end of the day. But we use most of the things use call data. Yeah, but storage is possible.
What are the time logs for?
Sorry?
What did you use the time logs?
Oh, so the time logs we're using for the voting. So we wanted to make sure that, so let's say you're voting right now, and then you're transferring the tokens, and nobody can vote on using the tokens that are received from you, for example.
I see.
Does that make sense?
But wouldn't it make much more sense to bound it by the block? So if at block X the voting period starts, I can only prove that I have balance X at block X. I have balance Y at block X, and everything after that is invalid. So you wouldn't need time logs.
True, if I had a proof that I had the balance at that block, right? Is that what you're saying?
Yeah, if you had some kind of proof.
Yeah, we have no proofs right now, but you're definitely right. That would also have been a good solution. That is true.
And the second question is, like all of this, so every action is done on chain, which means every time a user votes, that's done on chain.
Yeah.
Isn't that kind of a incentivization mechanism? Because if we force all of the voters to DAOs to spend money every time they have to vote on a proposal, they're not going to.
Because that's too expensive, you mean?
It costs money. Like a lot of times, so even if you're like participating in your like regular elections, and it costs you $100 to participate in the election, like you just incentivize.
Absolutely.
Do it.
Absolutely, 100%. I agree with your point. Yeah, it costs not little, a lot of gas to vote right now.
Right. So is there like a solution around it?
I mean, I do agree that voting, let's say off-chain and validating the votes is a lot more gas efficient. The bet here is that those computations are going to cost less and less gas with time, and also that it's going to become more efficient and quicker. That's really the only way.
FHE on chain has to prove it on chain. Is that possible? I don't think it is. I mean, you could. You'll have to do the BM again, and you have to participate in the FPC, and then you essentially become better. Yeah, makes sense.
Sounds good. Okay, thanks, guys.